Hello, students, and welcome to today's lecture where we are going to be going over molarity and the almighty mole. Okay, today's lecture is another kind of important one, but I think it's an easier concept than some of the easier lectures have been. And the reason that this is going to be important is this is how we make solutions, and solutions are really the workhorse of chemistry because we use them to go ahead and mix chemicals together. So being able to make concentrated solutions at the correct concentration is going to be vital for you being able to work in a real chemistry setting. Okay. And what we're going to go ahead and talk about here is the fact that the mole is the almighty unit of chemistry. All right? It is our baseline unit. So, in general, if we have a way that we can go ahead and get something to a mole, we will do so. All right? So anything that we can do to get to a mole, we're going to go ahead and do that exact process. All right. And one of the things that we have done in chemistry is we have made a unit that's called molarity. All right. And molarity is really our concentration for a solution. Okay. So molarity is our concentration. And I just realized here that I need to open the Lazy Chemist Lounge so that we can do some math in just a second here. So, molarity is going to end up being moles of solute, and it's going to be divided by the liters of the solvent. Okay? Now, I want you to think just a second ago. We said that moles is the unit that we want to get to. This is a unit that is in moles. Therefore, we could go ahead and take a closer look at this and we see moles of solute divided by liters of solvent. Moles of solute divided by liters of solvent. Okay? Which means that if we want to figure out how many moles of solute we need to add to something, or if we need to get to the moles, all that we have to do is get it by itself. And if we're dividing by the liters of solvent, we would have to just go ahead and multiply by any, well, not any, but the correct amount of liters in order to get rid of liters, all right? So this divide by, we just have to get rid of it, all right? And that's the main purpose of, or the main way that we do molarity calculations, okay? We get rid of the liters, and then we have moles, and for moles, we can actually do our, regular stoichiometric process, okay? So we're gonna start with this here. You need to make 500 milliliters of a 0.25 molar solution of copper 2 sulfate. How many grams should you add to water to make it? All right. So, this is a fairly typical problem. All right. Oh, man. Come on. Sign in. Let me in. All right. So, this is a fairly typical problem. All right. Notice, when we start this, we are going to go ahead and start this with the unit that has moles, okay? Because that's going to be the easiest unit for us to isolate. So this is 0. What the heck kind of drawing thing is this? New. Blank. Create. Okay. So we have 0.25, and we determined that this is moles over liters. Okay? So this is moles over liters. All right? And our problem says that we're trying to make 500 milliliters of solution. Okay? So we're trying to make 500 milliliters. But wait, liters does not equal milliliters. Okay? Liters equals 1,000 milliliters. Okay? Therefore, we could take however many milliliters we have. So in this case, we have 500 and divide it by 1,000. Okay? So 1,000 milliliters turns into a liter. And, oh man. That would give us 0.500 liters. Okay? So you see what I did there? What I essentially did was I said, oh, okay. Well, we have 500 milliliters instead of 1,000. Therefore, to turn it into liters, it would be 0.500 liters. Okay? This now is going to give us the moles that we're looking for. Okay? And we know it's going to give us moles because our liters is going to cancel out here. Okay? So here we have 0.25 molar times 0.500. Which means that in total we're going to have 0.125 moles. Okay? So we're looking for mole. Well, we have moles. Okay? Now we go back to our question. We see, okay, well, it's not asking for moles. It's asking for grams. Okay? But luckily, we have already done practice on moles to grams. All right? So if we're trying to go from grams to moles, or moles to grams, we're going to have to do a molar mass conversion. Okay? Let's see. Real time. Let's see how quickly Mr. Bradley can figure out how to get rid of this. Okay, well, that wasn't it, but we already determined that we had 1.25 or point. Oh man. So 0.125 moles. Okay, we're going to draw our conversion. At the bottom, we're going to put moles because that's what we want to get rid of. And on the top will be grams. And our original thing was copper sulfate, which is CuSO4. You guys already know that I have been obsessed with this chemical lately because I've been doing a lab with it all for a couple of days. Okay, 159.609. Okay. So then here, we'll go ahead and have to multiply them together times 159.609. Which means that if I wanted to make 0.25 molar, and I wanted to make 500 milliliters of it, I would have to measure out 19.95 grams of copper sulfate. Okay? And that's how all of these problems are going to go in some form or another. Notice that for our main thing, what we were doing is that we were just using the fact that we're trying to manipulate our units to get the answer that we want. Okay? Now, what I want you to notice as well is that in general, I'm going to have us use milliliters. The main reason that we're going to use milliliters instead of liters is because oftentimes in chemistry classes like this one, you're not going to be using entire liters of a solution. You're only going to be using a little bit, so I want you to get used to using a little bit. Okay? So here we have a second type of practice problem. And in this type, it's going to be slightly different in the fact that we actually have not been given the moles for this problem, which, oh my. It means that we're going to have to figure out the moles for this problem, okay? So, what we're going to do first is we're going to go ahead and crop and resize, right click, cut all. I guess that's how you do it. Okay, so we need to get two things here. Okay, we're going to need to get the number of moles. Okay, and we're going to need to get the number of milliliters, okay, or the amount of liters. So, go back to our question here. We have grams. We don't have the number of moles. What we do have is the milliliters, okay? We could turn that milliliters into liters. All that we have to do is divide this by 1,000, okay? So, we still need number of moles, but we also know that this is going to give us 0.650 liters. Okay. Now, we have to figure out the number of moles. Okay. We have 6.45 grams. Okay. And this is zinc. And we start with grams, therefore we want to get rid of grams. We don't want grams anymore, but we do want moles. So we'll put moles on top. And we're going to have to end this, of course. We're going to have to put in numbers. 1 is going to go with mole, and then we'll have to go ahead and find zinc. And zinc, luckily for us, is 65.38. Okay. We have to take 6.45 divided by 65.38. And that will give us 0.098. 6, blah, blah, blah. We have 3 significant figures, so we need one more from our answer, 5. So that means that this one we're going to round to 0.0987. We need to go ahead and from here put this number into our number of moles, because this is how many moles we have. So 0.0987, 0.650 L, and we have to just finish this out, okay? 0.0987 divided by 0.650. Okay, so we end up getting a molarity of 0.1518, and then we're going to round that last number to, oh wait, sorry, no, we're rounding to 3 significant figures, so this should be 2. So 0.1512, and then we use M to stand for molarity. Okay? And that's going to be it. Oh, and then we should, of course, include the fact that it's zinc. Okay. All right. And I think that we end up getting zinc sulfate out of it. So we're just paying attention here. I'm going to show you something else with that not too long here. But in general, this is how we're going to solve this second type of problem. Okay? Yeah, because zinc is always +2. All right. This is going to go ahead and close us out for this particular problem, or this particular problem type. In general, just remember you're probably just adding one extra step in order to figure it out. But in general, you get to moles, and then from moles you can go to grams, you can get to whatever unit you need to. Remember, moles is our home base, and that the whole reason that we use molarity, is because it is the almighty unit in chemistry, and it's the baseline for which we can go ahead and continue to be lazy for the rest of the time. So, until next time, remember to stay safe, and also, when you have the chance, remember to stay lazy.